Hi, boys and girls, welcome back. So today in science, we're going to be working on pages 10 through 13 in our science book, chapter 1. So if you have not already gotten your green folder and pencil, please go get it now. We'll give you a few seconds to go get that. So once you get your folder, open it up and take out chapter 1, please. Open up to page 10. So you can see I have quite a bit underlined here. I want you to also underline those parts. The title of this page says Other Kinds of Investigations. So the part that I really want you to be noticing is in that very first part where it says doing an experiment isn't always possible. So even though scientists like to use experiments in the scientific method, sometimes that just can't be done. You know, we talk about trying to ask questions that are testable. Well, the question, what kind of lizard have I found, is not a testable question. There's no test we can do that will tell us the answer of what kind of lizard. Okay, so in order to find that answer, you'd have to use something like an identification guide. So if you look down at the paragraph, you can see I have the question underlined. What kind of lizard have I found? That is the type of question that needs an investigation. So for this investigation, we would use something called an identification guide. Then you can see there's another question. What causes the sun to seem to rise and set? All right, so we can't do an experiment on the sun. It's way far away up in outer space. Plus, it's so hot, we can't get that close to it. So sometimes scientists have to use models. They create a smaller version of a real thing to try to answer their question. So for that particular question, you would make and use a model of the Earth and Sun. Okay. Another question I'd like you to notice is it says, at what time of year does a state get the most rain? Well, sometimes we use identification guides, sometimes we use models. For this particular question, we would look for patterns in data. So meteorologists keep track of how much rain falls every day of the year, and then the meteorologists could observe those patterns, observe the data and look for patterns to see if they can find anything that would answer that question. And the last question that I have underlined is, how did people who lived 100 years ago describe Mars? Again, there's nothing that you can do that would be an experiment to answer that question. So for that one, you would have to do research. So research is where you're reading what other scientists have written about, or you're talking or speaking with experts. So maybe you have the chance to talk to someone who works for NASA, or you've read books about Mars and you were able to find out information. So other kinds of investigations can be using identification guide, making and using models, looking for patterns, and research. Okay, we don't always do an experiment. So when we look at the next page, you are going to get the chance to use an identification guide. And you can see that this is a page that I do want you to submit a photo to me to show me your finished page, just this page right here. So your directions say draw lines to match the lizard with its description. So we have 3 lizards pictured. Underneath, you can see one of them is a Texas horned lizard, one is a common chameleon, and one is a common iguana. But what you need to do is look at all the details listed under each title of each animal. And then once you figured out which animal is which, draw lines from the name to the animal, okay? And when you're finished, you can submit that photo to me. If you don't know how to submit a photo, when you are in Schoology and you're in this assignment, you'll see a plus sign, I believe, up at the top, or it's submissions. Then you hit the plus sign and it'll say a photo. And so you can take a picture of this and send it right to me. On the next page, it talks about how scientists share their results as evidence. And what is evidence? Evidence is data gathered during an investigation. Now, you may have heard the word evidence if your parents watch TV shows that have mysteries or crimes, solving crimes. The police always like to gather evidence. Okay, well, scientists like to gather evidence too. And the evidence is the data or the numbers or the information they gather during their investigation or experiment. And one thing scientists are really good at is sharing their information with others. Okay, that's part of the scientific method, sharing your data and your results with other scientists. So make sure you're reading that page, but I do want you to underline evidence is data gathered during an investigation. And you know what? Sometimes your evidence shows that your hypothesis was right, and sometimes it shows it was not right, and that's okay. It might give you a new question to ask to try to find the answer to. Then on the next page, I broke this page up into 3 slides. So at the very top, please underline what a conclusion is. You can see I have it underlined there. It's the explanation that's based on evidence. So your job is to read evidence that was collected. There are 3 different examples. And then you need to say what your conclusion is. What do you think based on reading that evidence? So let's go through the first one together. So the evidence says we used thermometers and found that when air temperature changed by 5 degrees, a chameleon's skin color changed. So reading that evidence, what is something I can say about chameleon's skin color and when it changes? What does the temperature have to do? Does it go up or get warmer, or go down and get cooler? Or it doesn't even say that. It could just be that it changed. So our conclusion would be chameleons change their color when the temperature changes, okay? And then you can write that on your line. Let's look at the next one. Okay, you are going to come up with your own conclusion about the air temperature. Okay, the air temperature is usually blank. You fill in the rest. Okay, read it and fill in what you think. And the last one here is a table showing the paper airplane wingspan. Wingspan is how long the wings are from one side of the wing all the way across the plane to the other side of the wing. And those numbers are measurements in centimeters. So these are paper airplanes. And notice the numbers are going up, starting at 5 centimeters, then to 10, 15, 20. And then this investigation was measuring how long the paper airplane could spend in the air. And they timed it. And the first time was 7 seconds, then 12 seconds, then 21, then 28. So you have to come to a conclusion. The starter says an airplane with a long wingspan. So take a look. Look at your table. Look at the longest number for the wingspan. And tell me what you notice about the time that it spends in the air. Okay, what do long wingspans have to do with planes staying in the air? Okay, so once you're finished writing that in, you are done for the book today. Okay, all right, my friends, I will see you tomorrow. Have a great day. Bye-bye.